Well, this is going to be a rather fast-paced talk because there are probably hundreds of hours that can go into this, and that's why I have resources to go into it in more depth. But anyway, this is about worldwide evidence for Noah's flood. You hear this from mainstream scientists, like Arthur Stroller, an atheist, said, mainstream science has no obligation whatsoever to attempt to refute flood geology. That's what we believe from the Bible. A hypothesis vaguely and confusingly worded, lacking in completeness of statement, and nearly devoid of evidence. He does say there's a little bit. So that's kind of their attitude. And Davis Young, a retired professor of geology at Calvin College, supposedly a Christian college, in the book, The Biblical Flood, he says there is no geological evidence to confirm the idea of a universal deluge. Whoa. He's a Christian professor of geology. Actually, he's retired. What do we do when we get statements like this? We get statements like this all through the culture. This is my theme verse for research. We need to hold fast to that which is good, that is the Bible. But then we need to examine all this evidence they claim, and do it carefully. If you examine only at the superficial level, you might know just enough to brainwash yourself. You got to dig carefully, and that's why research is so slow. I've been at it for 50 years, and I keep up with about 50 earth science journals in the Montana State University Library in Bozeman. That's part of my research I do. I find all kinds of data that the secular scientists bring forth for us, but I can erase their interpretations. There's a difference between the data, the observations, and the interpretation. The interpretations according to their worldview, very important to understand that. But their data, their observations sometimes are very key to supporting the flood, which they don't know of. Before I get into the talk, we got to dismiss a few things. Was it a global or a local flood? Some Christians believe it was a local flood, but the Bible doesn't really allow that. Genesis 6-9 is written in historical narrative, and there's many indications that it was a global flood. The context, 30 universal statements. Also, the ark landed in the mountains. If you're in a boat in a local flood, you're going downstream. You're going to end up in a floodplain or out in the ocean if you're really unlucky. But the ark ended up in the mountains. That's exactly what you expect in a global flood, because the first place you see are the tops of the mountains. Also, why bring all those animals on the ark? It makes no sense if it's just a local flood. 371-day flood is hardly local. And I have forecasted floods in my career with the National Weather Service. Covenant of the rainbow makes no sense. Animals were told to repopulate the earth. That'd make no sense if it's just a local flood. And the sons of Noah were told to populate the earth. So the biblical evidence is hands down that it was a global flood. Here's a typical statement, Genesis 7:19-20. The waters prevailed more and more upon the earth, so that all the high mountains everywhere under the heavens were covered. The waters prevailed 15 cubits. That's approximately 22.5 to 25 feet, depending on the length of the cubit. And the mountains were covered. Well, that sounds like it's global to me. And here's a little cartoon from Answers in Genesis. Look at that beautiful rainbow. It's a promise from God that He'll never again flood the entire earth as He did in Noah's day. My Christian college professor, yes, most Christian colleges will teach a local flood, evolution, and deep time, the millions of years. My college professor said that Noah's flood didn't cover the entire earth. He told you it was just a localized flood. That's what he said. So he believes that God promised to never again send a localized flood. You can see the contradiction. The Bible obviously teaches it's a global flood. And some people think, the ark is too small for all those species of animals. Well, the ark is actually quite huge. There's a picture of a bus and a railroad box cars down there. Dinosaur. You don't have to bring the big dinosaurs in the ark. You can bring the small ones. And by the way, you do not need the millions of species put on the ark. It says 2 of each unclean kind. And that's what's emphasized in Genesis 1, where it says everything's to reproduce after its own kind. 10 times it says that in Genesis 1. That's not evolution at all. Now, if the kind is at the genus level in the biological classification system, you need only 16,000 animals. If it's at the family level, which most creation scientists believe, need only a few thousand animals. And within the genes, genetic code of those organisms, you have all the possibility of all the varieties, like all the varieties of dogs, for instance, all the varieties of elephant types, including woolly mammoths and mastodons and living elephants, and a lot of, so you don't need that many animals in the ark. What did Jesus say about the flood? Did he address the flood? Indeed he did. He said in Matthew 24, 37 to 39, in the context of the last days, "But as the days of Noah were, so shall also the coming of the Son of Man be. For as in the days that were before the flood, they were eating and drinking, marrying and giving in marriage until the day that Noah entered into the ark." In other words, they weren't paying attention to the signs of the time. Jesus believed in a real person called Noah and an ark. "And they knew not until the flood came and took a few of them away in a local flood in the Tigris-Euphrates Valley." No, took them all away. "So shall also the coming of the Son of Man be." But that word "all" sometimes means all the region, not necessarily all the earth. That's true. Sometimes it's used that way. But Jesus is comparing his second coming with this flood. In Revelations 1:7, it says that the second coming is going to be, all eyes will see him, and that's a global coming back. He's not going to compare a global coming back with a local event, is he? But with a global flood. So when he says it took them all away, took all the people of the earth away. So that's just the preliminaries. Let's get to the main talk. I'm going to talk about 4 things. Evidence for the flood, and that's global. You see this evidence worldwide. From hundreds of flood traditions, from what's called strata, that's jargon, geological jargon for sedimentary rocks. And from fossils, there are billions, if not trillions, of fossils in the sedimentary rocks. And what's called geomorphology. Geomorphology is the shape of the earth, like a mountain range or a valley. And I'm going to talk about 3 main aspects of this. Planation surfaces, I'll be defining these. Long transported hard rocks. And in this area, it's quartzite, which if you went on my field trip, you would have seen some quartzite, because this area is mainly quartzite, and metamorphic equivalent for shale is argillite, and water and wind gaps. Okay, evidence from flood traditions. Well, you've probably all heard that there's many people groups from the whole world that have a global flood tradition long ago. It's greatly distorted, but they still have it. It's in the hundreds of these flood traditions. So here's a graph that compares the biblical events with various flood traditions. And if it's a green square, it means a full representation. If it's a red triangle, it's a partial. Now, the reason it's partial is sometimes it's difficult to understand exactly what these flood traditions are saying. So that's why you got to give it a partial. But you can see that a lot of them are very similar to the flood narrative. And especially the ones in the Assyrian Babylonian ones, one of which is the Epic of Gilgamesh. And of course, you've got to have a theologian say that, well, Moses borrowed the flood from the Epic of Gilgamesh. Has anyone heard that idea? Just a few. Anyway, the Epic of Gilgamesh, the boat is described as 120 feet long, 120 feet wide, 120 feet high. What is a boat in that shape going to do in rough water? It'll go like this. So, but the boat in the ark is very reasonable because it has a length to width ratio of 6:1, which is very reasonable. That's similar to ships and barges today. So we know now what the origin is. It's from the Bible. And these others have been distorted with time. If you've ever played the telephone game where you speak to one person about something and then he speaks to the next person about this same thing, down the road, by the time you get to the end, it's so distorted you can't hardly recognize it. That's the telephone game. And that's how it was when people spread out from Tower of Babel. They knew of this event, but it was their thinking was becoming unclear, and they distorted it, added polytheism to it, etc. Okay, second piece of evidence, the evidence from strata, sedimentary rocks. I made a point in the field trips yesterday that the sedimentary rocks themselves is a powerful evidence for the flood. Well, first of all, let's talk about the flood. This is a little diagram that I use. You can divide the flood up as any flood into a flooding stage where the water rises, reaches a peak, and then it retreats. So you have two stages of the flooding stage and the retreating stage. And it peaked about day 150. So, and you can even divide it into phases. The first phase is at the very beginning. And the 40 days and 40 nights of rain is probably significant to tremendous catastrophism. And since I believe that meteorite impacts were part of the early flood, if an impact hit the pre-flood ocean, it's going to blast water up into the atmosphere and space, and the upper winds are going to carry it all over the earth, and it's going to fall as heavy rain globally. So that can easily account for the 40 days and 40 nights of rain. And I think the first 40 days are phase one because it's the most significant, the most catastrophic. We had meteorite impacts, we had volcanoes going off, we had huge tsunamis, a lot of earth movements, and so very catastrophic during that time. From day 41 to day 150, the rain let off, but the fountains of the great deep and the windows of heaven weren't shut until day 150. And probably during that period, the chaos was decreasing. Currents were decreasing. Turbulence was decreasing. So that's when the vast majority of sedimentary rocks were deposited, probably between day 40 and day 150. Now, between day 0 and day 41, it was so chaotic with powerful currents, maybe going 200 miles an hour, forming the great unconformity that we see on top of the upper crust, that the only place that you're going to have sedimentation are in deep basins or in rifts, which are deep cracks in the earth. And this area, the belt supergroup, I believe, is an impact crater. And based on the measured sedimentary rocks in this, the belt supergroup, which extends from Bozeman, Montana, and Helena, Montana, clear to Spokane, Washington, into central Idaho and up into British Columbia. It's generally circular. We don't expect impact craters that started circular to stay that way because of deformation of the crust. And the sediments left are at least 12 miles thick right now. But the top has been eroded because with impacts, you get, with the top blasted off, you get an isostatic balancing that wants to come up with time. And so we place this in the retreating stage where the mountains rose, the valley sank down to drain the floodwaters, and the floodwaters eroded maybe the top 3 or 4 miles of the belt supergroup. So it was probably around 15 to 18 miles deep. So you have a big hole there. And so I believe that was an impact crater, and it rapidly filled up from sediments coming from the west. We know that the vast majority came from the west by what's called paleocurrent direction indicators. So this area, I believe, is the very start of the flood. And as time went on, the sediments are deposited with their fossils. And then at the peak of the flood, the water starts running off, sometimes at high speeds. And the process, it erodes the top of the sediments laid down during the flooding stage. You see this theme globally. And a good place to look at strata laid down during the flooding stage is in Grand Canyon, which is we look at road cuts when we look at geology in a lot of places. Road cuts are great, but this is the greatest road cut of all. 4,000 feet of exposed horizontal sedimentary rocks. Now, and you can trace these layers 200 miles throughout Grand Canyon. And these layers can be traced a lot further than Grand Canyon, by the way. Like this bottom formation is called the Tapete Sandstone. It lies on the upper crustal rocks, which are down in the lower part of Grand Canyon, the narrow part, which is granite and metamorphic rocks. You can trace this sand, that stone, it's about 100 to 300 feet thick, few shale inner beds, very small cross beds, very coarse grained sand. So it's a very unique type of sand, and we know it's right on top of the upper crust of the earth. It has quartz pebbles that are sometimes an inch in diameter. So it's probably the pulverization of granite. And it was deposited not only here, but up in this area too. It's called the Flathead Sandstone. Probably outcrops in some of these places above the belt supergroups. There's a few small outcrops of the Flathead Sandstone in some of these areas above the belt supergroup. And that's the first level, layer that has fossils in it. And that's what it looks like at the bottom of the Grand Canyon. There's small cross beds, very coarse grain. You can see some of the quartz pebbles sticking out. So it's very unique. And here it is in Cody, Wyoming. Same sandstone, but it's given different names. It's called the Flathead Sandstone here. And this is where you can trace it. It's mostly under the sediments in a great part of the United States. It lies on the upper crustal granites. It extends up into the Canadian Rockies and even in northeast Canada. So it generally covers half of North America. What does this mean? Well, if you understand how the secular scientists explain geology, they explain it by something called uniformitarianism. Now, that's the only big word I'm going to use, hopefully. How many have heard of uniformitarianism and know what it is? Good. It's essentially when they threw God out and they threw the flood out, they said, how are we going to explain all these rocks with their fossils? Well, we got to use something we think is scientific, what we see going on today. Okay, that's present processes extrapolated out to millions of years. That's called uniformitarianism. The present is the key to the past is kind of a little saying for that. So if they rely on present processes, well, what processes are we talking about? Well, for sedimentary rocks, it implies deposition. Well, you had to erode it from somewhere. So you have erosional events like a flash flood or a hurricane, and then they deposit sediments. But when you look at these sediments, they're small scale, very small scale. And they change from sand to maybe rock conglomerate or clay quickly, horizontally and vertically. Everything's small scale, but the sedimentary rocks of the globe defy that. You can trace many of these layers 1,000 miles or more, like the Tapete Sandstone. And other layers, as seen in the Grand Canyon, can be traced up into this area. There's up in our Rocky Mountains, there's a formation called the Madison Limestone. That's the same type of limestone as the Redwall limestone in the in the central, in the Grand Canyon that's just a little above the Tapete Sandstone. So we look at Grand Canyon again, and we notice that these layers are flat, one on top of another. Typical of sedimentary rocks worldwide, even in this area, as I pointed out on the field trips yesterday. What does that mean? Well, they claim this 4,000 feet of horizontal sedimentary rocks that are laid one on top of another with little or no erosion was deposited over 250 million years. Everything is deposited over many millions of years. Well, let's think about that. When you go to national parks and monuments, look for contradictions. And the best way to do it is to think erosion. What is erosion on a 250 million time scale? What should that tell you? Well, erosion on a million time scale is rapid. In 10 million years, all the continents of the world can be reduced to sea level. Just 10 million years. But you can't use that as an average rate, because as the mountains decrease in height, the erosion rate decreases too. But you could put a maximum on it. A number of secular scientists have put maximums on here, and they get something around 20 million, 25 million. I'll be more generous. I'll say 50 million is a maximum. So in 10 to 50 million years, all the continents in the world can be reduced to sea level. On a million-year time scale, erosion is rapid. Well, if that's the case, in 250 million years of sedimentary rocks, where is the evidence of erosion? Even if this was deposited in 100,000 years, there should still be evidence of canyons and valleys carved in the walls. You should see it in the walls. So here's a little illustration. The bottom layer is the granite of the upper crust, and here's 4 layers deposited, and we'll say in just quickly deposited, and give it about 10,000 years, it'd look like that. And then say it was dropped below sea level and more sediment came, it'd cover up, and you would see the valleys still there and the canyons. And it happens again. So you should see canyons and valleys all through the walls of the Grand Canyon. And you don't. It's generally like this. You can trace the same layers, formations as they call them, all through the Grand Canyon. Sometimes they will thicken or thin, but in general they say the same thickness. That defies uniformitarianism. So we'll go to a place that's nearby. This is the Southern Teton Mountains. You can see Grand Teton Peak right there. I'm in the Southern Tetons, and these are horizontal sedimentary rocks about 3,000 feet thick, and it's the almost exact sequence as the bottom 2/3 of Grand Canyon. And so 3 geologists studying the Tetons and the valley to the east called Jackson Hole. And by the way, at the Teton Fault, where the Tetons were going up and the sedimentary rocks were mainly washing off of the central Tetons, the granite of the upper crust was the top of the Tetons, but it also sank below what's now Jackson Hole. The difference is at the Teton Fault, it's a change of 30,000 feet, where the valley sank and the mountains rose. Just like it says in Psalm 104, verse 8, to drain the floodwaters, the mountains rose, the valley sank down. But these 3 geologists in this book, published in 2007, said this about those layers. The regularity and parallelism of the layers in well-exposed sections suggests that all these rocks were deposited in a single uninterrupted sequence. That's what their observations, that's what their eyes tell them. But do they believe it? However, they go to their theory with everything stretched out into millions of years. The fossils and regional distribution of the rock units show that this is not really the case. The incomplete nature of the stratigraphic record becomes apparent when the spans of time represented by each of the various formations are plotted on the numerical time scale. And here it is. To the left, it's in hundreds of millions of years. And here's the Flathead sandstone, the very bottom one on top of the upper granites. And the white space are gaps. Here's a gap of 80 million years between the Bighorn Dolomite and the Darby Formation. Here's the Madison Limestone, the same as the Red Wall Formation in the Grand Canyon. Well, with all those, by the way, there's gaps even within where they claim the rock existed. There are gaps at all scale. In fact, secular scientists that study that says that 99% of the record is missing. Besides huge gaps, there's little gaps everywhere. So they only got 1% of the rocks. But if this is the case, where is all the signs of erosion in that approximately 280 million years, or no, 180 million years? It's not there. Powerful evidence against uniformitarianism. So let's transition to the third piece of evidence for the flood. Evidence from fossils. How do you form a fossil? You have to bury it rapidly, or it's going to decay quickly. And it must be fossilized before decay. What's fossilization? That is where chemicals are brought in from the environment, especially silicon dioxide, calcite, and phosphate, and absorbed into the soft parts decay really quick, even though we do find actually now soft parts in dinosaurs. That's a whole different story. But anyway, you have bones and shells, and so the chemicals are absorbed in the bones and shells, and it's turned to rock. It's got to be done quickly before the bone and shells decay. So that's how you form a fossil. And that's why fossilization today is very rare. Very rare. You don't have the conditions. But during the flood, you had ideal conditions where you bury everything rapidly, and as you build up the sediments on top, the pressure of the sediments heat up. The sediments are probably hot already, but they heat up more when they're buried. And silicon dioxide, being one of the main cementing and fossilization agents, it becomes more soluble and moves in the water, and it can quickly absorb into the bones and shells. And that's why Ken Ham's statement, I think, it seems simplistic, but it's actually profound. Where he says, what's the best evidence for the flood? Billions of dead things buried in rock layers laid down by water all over the earth. And you see lots of fossils, and sometimes they're in massive graveyards. Here in Montana, west of Shoto, we have a graveyard of dinosaurs estimated at 10,000 duck-billed dinosaurs, all of the same species. And Jack Horner, formerly of Montana State University, said this is not due to an ordinary flood. This is due to a catastrophic inundation. They describe these things in those terms. This is a fossil graveyard of ammonites from Venezuela. So you see a lot of bone beds. And in southern Canada, Dinosaur Provincial Park has some huge bone beds of ceratopsians. Anyway, China has some huge bone beds of thousands of dinosaurs. Northeast Wyoming has big bone beds of thousands of dinosaurs. So it's typical to find these huge bone beds, which would be typical of the catastrophe of the flood. And you see all fossils like this, like fish eating fish. It was buried and fossilized before it can swallow its dinner. And of course, there's this marine reptile called an ichthyosaur, and it was fossilized at the point of giving birth. That's not an extra tail down there. That is rapid fossilization, burial and fossilization, exactly what we expect in the flood. And Kevin said that 95% of fossils are marine mollusks, which have a shell on the outside. And the interesting thing is most mollusks in the sedimentary rocks are closed-shelled. And the muscle attachments, they'll decay rapidly when the organism dies. The shell will open in days to weeks. The fact that we have so many closed-shelled mollusks like oysters, clams, brachiopods, indicates rapid burial. And this is a global phenomenon, so it's worldwide. And here's a sample from Oregon. My friend Dennis Buckavoy showed me various clams and oysters and brachiopods. A brachiopod is similar to a clam, but the shells are not exactly the same. It's a slight distinction. Okay, let's go to the fourth topic, which is my favorite, evidence from geomorphology of the shape of the surface of the earth. Okay, we'll get back to this diagram. Practically all the sediments were laid down in the flooding stage. And then when the retreating stage occurred, it occurs in two phases. And that's where you erode the top of these sediments off. And by the way, I and 3 others have a long research project to determine where the sediments lie, what do they mean, where do they come from. This we've been doing for about 8 years, and so we've got a lot of answers now, as I will just briefly get into here. But anyway, the retreating stage is 221 days, and at the first, everything's covered. So phase 4, you have wide currents moving across the earth. And then with more mountains and plateaus sticking up above the floodwaters are forced to channelize around these, forming phase 5. And each of these phases erode the land a certain way that we can see all over the earth. And I'm hoping you can, as you travel around, you can see these features. I'm only going to show 3. I only have time to show 3. But the big picture is that we had at day 150, we had approximately 10,000 feet of sediments average on the continents at the peak of the flood. This is what we discovered in the flood research project. And the first thing we want to know is how much was eroded off. And the way to determine that is where did the sediments go? Well, when they eroded off, the currents were going so fast, they were taken clean off the continent. And when they get to the edge of the continent, they hit deep water. And when they hit deep water, the currents slow down. And when they slow down, they will drop their load, forming the continental shelf. The continental shelf is an amazing feature. It's an unusual profile where the top of it shallows very slowly out in the ocean. And then they have a big drop-off called the continental slope. That feature is not an unnatural process. If it was slow processes of deposition over millions of years, you'd have a gradual change down to the deep sea. But otherwise, you have a profile that slowly goes out to sea, and you have a big drop-off. Now, the continental shelves can be anywhere, they average about 50 miles wide, but some of them can be 300 miles wide, like in the Bering Sea, the ocean off Newfoundland, the Grand Banks, and the Arctic Ocean. The continental shelf is very large there. And the sediments below this, which they can probe by seismic methods, which you send a sound wave down and it reflects off surfaces and bounces up to a receiver. You can tell the depth of the sediments off the coast. And a lot of places, the sediments are 12 to 15 miles thick, like off the east coast of the U.S., in the Gulf of Mexico, the Bengal Bay, and along the Arctic Ocean. Believe it or not, there's huge thickness of sediment out there. So based on that, I determined that the amount that was eroded from the continents during the retreating stage averaged 1,900 meters, or about 5,000 feet. 5,000 feet of erosion. The continents are greatly eroded and scoured. That's why when you go to farm an area, you have a thin soil, and then you get down to hard rock quickly. It's been scoured. And the significance of hard rock is that to form rock, you have to have a pretty good thickness of sediment to press the particles together like a sand, get the particles closer, then fluids cement it. But you have to have thousands of feet of what's called overburden. And a lot of places that overburden's gone. That's part of the 5,000 feet of erosion average. This is an average, by the way. Some places it was much more. I think in this area, the belt supergroup, you probably had several miles of erosion from the top. So, and then after you took off a great amount, it channelized, forming these valleys we have like this valley right here. And then what's left on the continent, we've been measuring this state by state. We're finding some interesting features. We're finding huge cracks in the upper crust. But we're finding an average generally about 5,000 feet left. This is an average. We've gone through the central and eastern U.S. We're finishing up the eastern U.S. right now. And I'm going to be finishing up a paper on the Appalachians when I get home. And so this is what we've collected. So 10,000 feet. Where did that come from by the peak of the flood? That's a huge amount of erosion. You know, it's going to take meteorite impacts to really churn up that sediment and break it up into fine grains. Most of the sediments, fine grain sediment, sand, silt, clay, it's been broken up. Unlike uniformitarianism, where you should find a lot of conglomerate, a lot of rocks, like you see around river floods. But this is broken up to fine particles. To do that, you need a lot of turbulence and fast currents, and meteorite impacts can do this. It'll break up the sediments and redeposit it. Where did it come from? I think a great amount of the sediments we find in North America came from what's called the Canadian Shield. But I won't go into that anymore because that is a 5-minute getting off the subject. Okay, let's talk about features of geomorphology. Planation surfaces. This is generally a flat surface. If it's rolling, it's an erosion surface. And one of my favorite areas to do research is the Bighorn Basin. This is a plateau west of Graybull, Wyoming. And you can see the sedimentary rocks tilted down to the west. And the top of this it's probably a dome that went up like that. It's been sheared off flat, both hard and soft rocks the same, which takes a powerful current. And on the top of this, you have about 15 feet of rounded rocks because there's water that did this erosion. And some of those rocks are quartzite from central Idaho is the closest location for here. Anyway, we've analyzed the planation surfaces on the high plains. There's generally 4 levels. These are the top 2 right here. The top is the Cypress Hills in Canada. The western Cypress Hills, first of all, the Cypress Hills are about 80 miles long, 50 miles wide. They've been dissected. Probably during the channelized phase of the flood, it probably cut through this plateau and channelized it. And then glacial rivers could have added to this also, because this area was glaciated. And the western Cypress Hills stuck up above the ice 300 feet. And it is 2,500 feet above the river to the north, the South Saskatchewan River, and the river to the south, the Milk River. It's a high plateau. And there's the northwest part of the Cypress Hills. I'd like to call it the Cypress Hills Planation Service, but you know, that's not going to fly because this is a very big touristy area in Canada. Here it is in the central part of the Cypress Hills. Now down in the valley, which I believe was eroded, probably either very late flood or post-flood or both, I have found giant erratic boulders from the Canadian Shield from the Ice Age down in that valley. So probably catastrophic meltwater from when the ice melted maybe enlarged this valley or formed it. I don't really know. And here's the eastern part of the Cypress Hills, and they're east in Saskatchewan. And when you drive up to it, it's as flat as a pancake, a planation surface. The key thing about planation surfaces is they're not forming today. They're being destroyed by present-day erosion, which is more linear. Streams and rivers carve up these things and destroy them. It's against uniformitarianism. There's no present processes to form these such things. And some of them are over huge areas. Now, Lester King, who's my favorite geomorphologist from the University of Natal in South Africa, says this about planation surfaces. He was a world traveler, and he discovered that these things were once much larger, but then they got broken up and dissected by tilting and other features, channelized erosion, to make them smaller. He says a planation of extraordinary smoothness developed over enormous areas in all the continents. It is a worldwide phenomenon because it was a worldwide flood. From it, that is, from these planation surfaces, most of the world's present scenery has subsequently been carved by renewed erosions. And here is one planation surface that is east of the Little Rocky Mountains in north-central Montana. And it was so flat that there was an airport off to the left side of the picture. It's being dissected by streams coming out of the Little Rocky Mountains. It's being destroyed. But notice how flat that is. These things are global, worldwide. They were once much larger before they were dissected. So here's the summary of this. Now, if a slow process of erosion over millions of years, when you have tilted sedimentary rocks, which are rather common, it's usually a combination of a hard layer and a soft layer. The hard layer usually being sandstone, the soft layer being shale. If a slow erosion over millions of years, that is deep time, the soft rock should erode first and the most, and some of the sediments should end up in the valleys. Hard rock should be ridges. We do see this pattern, and this can form by slow currents, but I think this is what we commonly find, and these are, I believe, are formed by fast currents that shear off these rocks to a flat surface and leave rounded boulders and cobbles on the top of them, rounded by water. Both hard and soft rocks the same. This is what we often find. This defies uniformitarianism. Planation surfaces are worldwide, indicating a worldwide phenomenon. Here's a summary of the planation surfaces. They're not forming today. They're being destroyed. They were once much larger. They're common as erosional remnants. They're worldwide. They're difficult. Actually, I'd rather say impossible, but I won't be so dogmatic. Difficult to explain by slow processes, uniform processes over millions of years model. Powerful evidence for the global flood on the surface of the earth from geomorphology. Let's talk about quartzite rocks spread hundreds of miles from their source. By the way, this is not unique to the northern Rocky Mountains. You see similar signatures globally from other mountain ranges, which I've gone into. The Alaska Range, I've documented that. The Mogollon Rim in Arizona. And from the literature, the Himalayas. But anyway, quartzite rocks. What is quartzite? Well, I showed some of you this that were on my field trip. How many were on my field trip? Not too many. Oh, okay. Well, I think there's only a few openings left for Sunday afternoon. But anyway, this is a quartzite rock found on the top of the gravelly mountains of southwest Montana. And it's well rounded by water action. And I chipped off a piece, and you can see the texture of it. It's a sandstone. It's a metamorphic sandstone. To form a metamorphic rock, you got to put it under higher pressure and temperature. And since sand and sandstone is mostly quartz, when it heats up, it recrystallizes and it fills up all the pores and becomes non-porous, and it's heavy. You pick one up, boy, I could tell what it is almost from just its weight. And it's one of the hardest rocks in the world. And when this area was uplifting and the floodwaters were eroding the top, it pulverized the softer rocks like argillites and basalt. You have a little basalt in this area. carbonates. We saw some carbonates down on the field trip, mainly dolomite. They're softer, but the hard rocks, they get eroded off and they get rounded, starting off with maybe big, huge, rounded boulders. And as they go further downstream, they become smaller and smaller. And this is generally the gray area is the belt supergroup. And the general area where this quartzite forms is in this area. Now, there are quartzites going east of this area, but they become what's called, the grade is less. But in this area, they're called high-grade quartzite, highly metamorphosed. And so this is the general area of the outcrop. And the big picture, now, I drew this wrong. The big picture is you have currents from the west. We know this from other indications that's eroding the belt supergroup and spreading the rocks far downstream. Now, this indicates that these are linear features. No, I need to redraw this, have my artist redraw it, and continuously fill in rounded rocks in between. So it was one huge sheet of this stuff moving out east. Clear out into Saskatchewan and Manitoba, Canada, and western North Dakota. I have found them in central Saskatchewan, western and North Dakota, a lot of places in Wyoming. And so as more mountains rise up, the current is split. The current that was going towards the east continues out towards the Mississippi River Valley, and then you get a backwash flow towards the Pacific. And it's carrying quartzites back towards the Pacific Ocean. And I found quartzite. I've been chasing these things for 40 years and found them on 4 mountain tops. You find the quartzites piled up in deep cracks like east and northeast of Jackson, Wyoming, that are supposed to be 11,000 feet thick. And then from I-15, just from the Montana border into Idaho, near Spencer, Idaho, if you drove up on a logging road to the west, you would drive up on rounded quartzite rocks that seismic methods indicate are 15,000 feet deep in some deep crack. We're talking about huge catastrophic action. And so the currents are split, and they spread the quartzites in both directions. And so here's a plot. It's rather messy, and the big green areas are huge. The huge thicknesses that are 11,000 feet east of Jackson will clear up into Yellowstone Park and west of Spencer, Wyoming. And then you have a lot of smaller areas. This is incomplete because I've discovered some right around Bozeman in southwest Gallatin Valley. There's a few plateaus there that are about 15 feet of rounded quartzite rocks from Idaho. These are all from central Idaho. And this is on the Teton Mountains. This is the late Brent Carter from Boise, Boise, Idaho. We did a 3-day hike up the top of the northern Tetons, and there's some of the quartzites found out. They're well rounded by water. That's the largest one we found. And here's another one. Now, I need to say another feature of these quartzite rocks. They are commonly covered by semicircular cracks called percussion marks. You can see them right here. Some of them have hundreds of these things. Percussion marks on quartzites are not forming today. We tried to duplicate these things with sledgehammers and can't. What I think this is tremendous turbulence, and they're banging so hard with maybe 200 mile an hour currents that they produced the percussion marks on these quartzites. And this is found on the top of the Teton Mountains, by the way. I see these percussion marks everywhere. And then going west, this is where we find them. On top of the Wallowa Mountains, right in here, and the Blue Mountains, find them all through the Columbia Gorge, and even on those lava ridges around Yakima. The tops of them, you find quartzites, and every single one of them rounded by water. The most interesting place is in the Puget Sound area, where a finger of the ice came surging down to Olympia. And I have found it many places north of Everett, even up into east of Vancouver, Canada. find quartzites mixed in with the glacial debris. And here is a picture on top of the Wallowa Mountains, 8,200 feet. And you can see some of the rounded rocks up in here. There's supposed to be one that was that in a meter in diameter, but it's probably under that snowdrift because we never found it. But we found one that was close. This is it. Notice how it's well rounded by water. Water rounds these things. And in the finer particles in there, there's gold, because there was an active gold mine on the top of the Wallowa Mountains that placer mined the quartzite gravels, if you can imagine that. But it was shut down because it became a wilderness area. And the closest area is central Idaho, and Hell's Canyon is between this location and the source. And in this area, we find quartzites all through the high plains, from the Cypress Hills down to what's called the Flaxville Plateaus, more planation surfaces. The Cypress Hill and under the glacial material in Saskatchewan, where I have found them in this blue area. And here's the Cypress Hills. The Cypress Hills, sticking way up above the rivers to the south and north, have 75 feet of rounded quartzites cemented together. This is what it looks like at what's called conglomerate cliffs. That's a close-up. And there's even a closer up. A lot of these have an iron staining. They're brown or orange. I think it was a high iron environment. For iron to be in the water, soluble, implies very hot temperatures, by the way. So I think there's a lot of heat. Creation scientists have not considered the heat of the flood yet, or the chemistry of the flood. We can use a chemist, by the way. And here's one of the largest percussion marks I've ever seen on a quartzite at conglomerate cliffs. That would take a powerful force on this very hard rock to form those percussion marks. What are we saying? Well, by open flow channel equations in civil engineering, we can put minimum current speeds to these. And this is the big picture. Currents coming off the Rockies, eroding the Rockies as the Rockies are rising, spreading the quartzite 800 miles from their nearest source in central Idaho into central Saskatchewan, southwest Manitoba, and western North Dakota. So the smaller rocks are moving along the ground, the surface, and eroding the planation surface down to a lower level. But the small to medium ones are being carried up in the water, and they come banging down at high speeds. I think that's how the percussion marks form. So we can put some numbers on this, which are minimums. So Peter Klebberg did this calculations. I'll pay attention to the bottom one. A 6-inch wide bullet-shaped quartzite rock. The minimum current speed to move that, 65 miles an hour, minimum depth 180 feet, coming off the Rocky Mountains over the Cypress Hills. That's kind of the big picture. So in summary, quartzites are spread 800 miles east from a source in the western Rockies, especially around here, the Belt Supergroup, west of the Divide. They're spread 400 miles west to the ocean. Percussion marks indicate torrential flow, powerful evidence for flood runoff. Powerful. And I'm going to shift to a third feature, water and wind gaps. My favorite water gap is west of Cody, Wyoming. It's through the Rattlesnake Hills. The Shoshone River starts in southeast Yellowstone and flows east through a valley and comes to this Rattlesnake Mountains that are 2,500 feet tall here. And if a slow process of erosion over millions of years, that river should have went around the Rattlesnake Mountains to the 2 miles to the south through a low area and come out into the Cody area. But did it do that? It appears the river wasn't diverted at all by the mountains, but ended up going right through it, from one side of the mountains to the other in this water gap. 2,500 feet through hard granite and sedimentary rocks banked up against the granite. You can see the sedimentary rocks banked up in here. And when you drive through the water gap, you come to Buffalo Bill Reservoir. And here's the water gap right here. You can see the low area to the south, where when the valley was a little higher, say 100,000 years ago, the river should have went out that way. Why did it end up going through the Rattlesnake Mountains? They don't know, and they try to guess their way through all these. By the way, there are thousands of these water gaps across the earth. Grand Canyon is just one. But it's not the deepest canyon in North America. The deepest water gap is Hell's Canyon, where the rock is 8,000 feet high above the Snake River on the Idaho side. Now, if it was slow processes or uniformitarianism over millions of years, the Snake River should have continued out into southeast Oregon and ended up in the ocean somehow. But instead, it takes a right-hand turn and ends up going through a 50-mile-long water gap to enter near Lewiston, Idaho. Why did it do that? Well, they don't know. Like I said, there's thousands of these. This is kind of a quickie on it, since I'm running out of time. We start off with wide currents. The ridges are coming up, and the currents are going perpendicular to it. And usually no ridge is flat on the top, and it has low spots. Low spots will be areas where the water will really take advantage and eat it out and erode it quickly, like this with time. And accelerate, it has to accelerate. The same amount of water going over a wide area has to go through more narrow areas. So when it accelerates, it erodes faster. Erosion rate goes up approximately 16 times the speed of the current. Like if you double the current velocity, the erosion rate goes up 16 times. So as time goes on, you have the water rushing through these gaps, eroding them quickly. And for some reason, the one on the left gives up, and all the water goes to the other one. And at the end, you have a gorge through the mountains called a water gap. And the rivers and streams naturally take advantage of that low area, flow through that. Well, the other one that gave up too soon for whatever reason is left high and dry, and only wind goes through it, called a wind gap. There are thousands of wind gaps across the earth. So let's get to the question. I have only a few minutes. Why can't mainstream geologists see all this powerful evidence for the flood? It's abundant. It's everywhere. This I picked up on my own, and being a shift worker for the National Weather Service and having sleep problems. I was a zombie for 25 years, I might add. I picked up this book from William Dement, who was one of the discoverers of REM sleep. He says on page 34, even when they are looking, people usually see only what they expect to find, and they do not see what they assume for whatever reason could not exist. Secular scientists are so ingrained into deep time, slow processes, that they can look at features and totally miss it. We do the same with, also, by the way, it's a psychological phenomenon. So the Bible makes sense. In summary, Jesus believed in the global flood, and if Jesus believed it, I'm certainly going to do that. The ark is big enough and very stable. The flood is one of the most despised events in the culture, yet there's abundant evidence for it. Therefore, it is easy to believe the whole Bible, the flood being such a despised feature. And the Bible tells us how to live here on earth and how to go to heaven. We can trust the Bible. This issue is about biblical authority. And what does that last one say? Well, Romans 10:9 kind of summarizes, just like John 3:16. If you confess with your mouth that Jesus is Lord and believe in your heart that God raised him from the dead, you will be saved. And these are commitment verbs. You got to commit to Jesus as your Lord and Savior. So we do have a lot of answers that we developed. Anyway, this talk is generally featured in this book, How Noah's Flood Shaped Our Earth. I actually start with what do we know about the pre-flood earth? We do have some pretty good clues in the rocks and fossils in the Bible. And it goes through the early flood, late flood, and what the flood caused afterwards, the Ice Age, which I'll be talking about this afternoon. And this is a recent book because we want to educate people in geology, especially geology is where they put it over on people. You can easily show evolution's false by biology, but when they say the rocks show simple to complex organisms with time, there's your evolution. Presto, we proved it. But biblical geology is teaching about geology, enough information for you to see for yourself the abundant evidence out there. And I've done a children's book because I'm passionate about teaching geology to young people to get them started. So we did this nice, fun cartoon book on exploring geology with Mr. Hibb. We have also exploring dinosaurs with Mr. Hibb, and I'm finishing up exploring the Ice Age with Mr. Hibb. That's not out yet. Also, this book, many people have said, what about the millions of years, the age of the earth? And those radiometric datings seem so powerful. They do seem pretty powerful, but there's another story. I wrote this book, The Deep Time Deception, examining the case for millions of years for those with no science background. The other books on radiometric dating, even the layman ones, are too complex to understand for most laymen. So I think most laymen can get through this book. And for those that are totally new to this, we have the answers book. There's lots of questions. We have lots of answers. We still have a lot of research to do in many other areas. Also, I have these DVDs that Kyle Justice did, and these are not ordinary DVDs. This one is about this talk, the receding floodwaters. I'm out in the field showing you the various features. I'm not at a podium like here. I'm out there in the field showing you. It's about 100 minutes long. And I want to leave you with this verse and then some websites. Your faith should not rest on the wisdom of men, but on the power of God. The wisdom of men is trying to explain everything without God, you see. It should be on the power of God, because God has the power to do it all. And here's a bunch of websites, including my own. I recommend creation.com. It has 13,000 articles for all scientific abilities, from children to professors. 13,000. It covers all fields. So that's all I have for this morning, and I'll talk about the ice ages this afternoon. Thank you.